This is artificial intelligence learning how to ride a motorcycle without any human interference. As you can see, this AI still hasn't quite mastered the art of biking, but that's because it's only been alive for the past 2 hours. With every second that passes, this AI gets smarter by learning from its past experiences, and by the end of this video, we'll see just how skilled this AI becomes, and hopefully, it'll learn to stop crashing. But that begs the question, how do we teach artificial life new skills that it's never had experience with before? It's actually very similar to the way that you and I learn new things. Reinforcement, learning. Let's see how it works from the beginning. First things first, let's give this AI a name. Ted. So right now, Ted knows absolutely nothing, and our objective is to get him to cross this finish line as fast as possible while avoiding these obstacles. We'll make the environment more complex later on, but this is a good starting point. So the first thing we need to do is give Ted the ability to sense the objects in his environment. We achieve this by having him shoot a bunch of lasers from his body. If these lasers collide with an object, Ted will know where that object exists in relation to his current location. We'll then take all these observations about the environment and input them into an artificial brain we've given Ted called a neural network. It's actually straightforward how it works. A neural network takes in inputs and generates outputs. The inputs are the observations that Ted collected from the environment, and the outputs will be the actions he should take, such as pressing on the gas to go forward or steering left or right. Now that we have the neural network set up, we can begin training. Initially, the neural network is just going to output completely random actions. Imagine you gave a chimpanzee a video game controller, and the chimp just smashed a bunch of buttons. That's pretty much what's happening here, and it's not too impressive. But what makes neural networks special is that they can learn through trial and error, and over time start to output better and better actions. We don't explicitly tell the network what actions to take, we just provide it with high-level feedback on whether an action it took was good or bad. We call this a reward. We'll give our friend here the following rewards. We'll give him a positive reward for every second that passes in which he gets closer to the finish line. We'll provide a negative reward when he crashes into obstacles or falls off his bike. And we'll give him a massive reward for actually crossing the finish line. There's actually one potential problem with the way we set our system up, but I'll touch on that later in the video. For now, let's just keep training and see how well he learns. We can see that within a relatively short amount of time, our AI is able to associate the act of pressing on the gas with higher rewards, and so this behavior will be reinforced. And behaviors that resulted in lower rewards, such as going backwards or just mindlessly bashing the left and right keys, will slowly become less common. In other words, our chimpanzee is getting smarter. Although, it looks like he doesn't quite yet know how to properly deal with these obstacles, but he's slowly getting there. You may have noticed that Ted is spawning in a new location at the beginning of every episode. We do this to prevent the neural network from overfitting, which is when a neural network just memorizes the exact moves to take, but doesn't actually learn intelligent behavior. Remember, our goal is to teach Ted to ride a bike, not just ride a bike for this one specific map. By changing his spawn location by a little bit, intelligent behavior is more likely to emerge. After struggling initially, Ted eventually discovers that the best way to get a reward is to drive through the gaps between the obstacles, and so he seems to be getting better and better at understanding his environment. He does take a while to proceed further though, especially over the ramp. The ramp's new to him, and he's not quite sure what to make of it, until finally, Ted builds up the courage to drive over the ramp, and because this is the closest he's ever gotten to the finish line, it's the highest reward he's received to date, and thus, this behavior will be reinforced. From here on out, it's pretty much smooth sailing. After a bit more training, Ted successfully crosses the finish line. Let's just see him do it one more time for good measure. And there we go. So this is a great start, and you may think it's time to celebrate, but there's still something else we need to do before we can say that Ted is an expert. So unfortunately for Ted, we need to hold off on the celebrations right now. And let's travel to a new world. This is a brand new environment that's more challenging for Ted to master. We're going to use the same exact neural network that we trained in the previous environment and see how well it works on this one. So unfortunately, it's not working that well. Remember how I said there was an issue with how we set up our system? Well, one big problem is that Ted can't actually see in this environment. Those lasers that he shoots out, they seem to be shooting over the railings on the side of the road, and so he effectively is completely unaware of his surroundings. The fact that he is going downhill, instead of driving on a primarily flat surface, is also something that the current neural network will have trouble dealing with, since it hasn't trained on that. So I'm going to change how we set up our system, and start the training over from scratch. These problems ultimately highlight one of the key challenges of reinforcement learning and artificial intelligence in general, which is that it's incredibly difficult to create a model that generalizes instead of specializes. Our neural network is currently specialized for that one map. Although we tried to improve the neural network by changing around the spawn location, it ultimately wasn't enough to be able to handle this new environment. I'll skip over the boring parts of the training and just show you some of the highlights. Some of the changes I made for this new round of training is that I added some additional inputs to our neural network, such as more lasers, the current rotation of Ted, and whether he is currently on the ground or not, which is useful information us humans take for granted, but is not something Ted would know unless we explicitly tell him. And finally, once again, Ted crosses the finish line. I think this time it's worth celebrating. Thank you so much for watching this video. Many more videos about AI and reinforcement learning will be released on this channel in the near future, so please subscribe and like this video if you enjoyed it. Thanks everyone. See you next time.